Hi everyone. For today's video, I'll be covering, part 15 of the Metroidvania series, where we'll be creating a save system for our game. I know we already have one, but there are a couple of bugs that our current save system has. For example, the saving is a little bit spotty. Like if you save without sitting down on a bench, for example, when you change scenes, you will save. If you kill yourself, the game also saves. So if you save without bench, you can get weird bugs with the save system. And if you try in the current system, right, to after you die, you create a shade and then you leave the map and you come back, then the shade disappears. All right, and the current save system also doesn't save pickups. So there are a couple of issues with the save system that I'm looking to solve with today's series. And as part of solving these problems, right, we're also going to introduce a multiple save slot setup for our Metroidvania save games, which is gonna be really cool. And this part of the series took so long to develop, and that's partially because I was developing the asset for the save system itself. Initially, I was just going to create the scripts and then share the scripts in the blog, but then I realized that there were so many different scripts, and it would be very difficult very difficult to explain everything in a blog, because there are so many advanced concepts that are used when I was writing the script for the save system. So instead of writing all of this into a blog, which would have took me a couple of months, I instead am releasing the save system onto the Unity Asset Store as a free asset. And of course, in the future, we're going to look at how we can offer paid extensions to the free asset. But right now, what we're gonna do, because the asset is currently in the midst of approval, right? This part of the series will be based on how you integrate that asset that we are releasing into your game. And the asset is called Bench. It's the Bench Universal Save System. It can be used for any game. It was initially developed for this Hollow Knight tutorial series, and that's why it's called Bench. And without further ado, let me just get right into it. So this bench system was developed with the it was meant to replace the current save system that we have. And because I've decided to develop it generally, right, to apply to all games, there was a lot of work that went into making the save system easy to use, and also just very easy to set up. Still, there's quite a bunch of steps, because no matter how you simplify saving, there's still quite a lot of details that we have to pay attention to. So let's jump right into the project itself, and I'll show you what are the aspects that we have to pay attention to. So there were a couple of problems with the old save system, as I spoke about. In addition to the points I've mentioned, we also have an issue with a couple of issues with the way that we did the saving. So one thing that we did was we used the binary writer object to save our games, and you will see that the save happens actually, it saves in multiple files. So the player has its own save file, the bench object has its own save file, and then we also have the other one was, I think, the shade. Maybe I can just recreate the saving over here to just demonstrate this. And it's a little bit troublesome to find the save files as well, all of which the bench save system actually solves for us. So this is using the old save system. A couple of problems with it. If I do a save here, we can right away see. Let me just open up the save file. So the old save system actually saves all the data inside the, let me see if I can get the icons to be bigger. It actually saves 3 files, one for the bench, one for the player, and one for the shade. And the whole thing is just all over the place. And then you also have the saves are in binary, which presents its own set of problems, because the saves are in binary. it's you can go and Google C# binary writer Unity, and you will get a bunch of articles about how the binary writer is unsafe because there is no checking of what kind of objects you're creating with the binary data. It's a very technical subject, but because of that, the bench universal save system that was created for this part of the series, right, uses a different way of saving as well. It saves in XML as opposed to saving in binary, and this solves quite a few problems that we will have with saving using the binary writer. And well, the saves are also single slotted, which presents its own problems. And finally, there is a problem with the save files because we cannot see how the data appears. And this is contrasted with the new bench system, which I've imported a sample of this into this project, and you will see in the new save system, right? You will be able to. It's not really a good example, but later on when we integrate the save system, you will see that you can very easily see all the save data on the editor itself, as opposed to having to look at. There is no way to debug our data. Like, I mean, how can you debug this? How do you know what is being saved here? And how do you rectify if there are any bugs? So because of the trouble of viewing this save data that we have, right, it was very difficult for the previous developers of the Metroidvania series to debug the saving, and that was why our saving all the way until part 15 now has been a little bit buggy. Okay, so when this video is cut, we will direct you. There will be a link to the published bench universal save system asset. Right now we don't have it yet, but when my editor is editing the video, we'll plug in the URL as well as a screenshot of where you can find the download. Right now, if you want to follow this, after this recording, a download link will be made available to anyone who wants to follow the series. Download the bench save system asset before it is made available in the Unity Asset Store. All right, so once it's in, right, what we want to do is, I mean, here are a bunch of reasons as to why we can use the bench save system. Let me just show you right away, right, how this can improve our game. So how the bench save system works essentially, right, is that basically you want to mark all of the scripts that need to be saved by extending persistent object instead of extending mono behavior, which is the default for all objects that you want to attach as a component in your projects. So you also have to add the using TerraSquare namespace. That's because all the files in the bench save system will be under the TerraSquare namespace. It's just to prevent conflicts with other classes that also maybe perhaps use persistent object, but maybe for different purposes. All right, so you extend the persistent object, and then after that, you will add a save function and a load function. These two functions define how the data is saved, what data is saved as well, and this determines how the data is loaded. And then finally, we have inside here every one of our classes that wants to be saved. There will be a save data nested class. This is meant to replace the main save data script that we have right here. So currently in our project, we have one big save data struct that we use to save our data, and this save data struct is responsible for saving the 3 files that we just saw earlier in the video, right? So you will see here there's code for writing 3 different files. Okay, all of this stuff is now going to be handled by our asset. So this makes the whole process of saving much easier, and it also allows us to save everything into one file, and then the inspector will show you all the data that's saved as well. So let me just implement this pickup script. One thing I've done here as well is in our old pickup script, we destroyed the object after it was used. Instead of destroying it, we're now going to set this to be inactive, and the reason for that is because when the game is saved, right, if the object is deleted, then the bench system will not be able to pick it up. So instead of destroying this object when it's picked up, I will just set it to be disabled. So then whenever there is a save, then, you know, whatever item that is picked up, if we need it to be saved, it will still be saved. So I'm just going to copy this pickup script and drop it into my own project here. And there shouldn't be any errors right here. I just want to show you how this affects our pickups in the game. So once we drop this in, right? Okay, you will see that all of the pickups, because this affects the parent pickup class, which in the last part we converted all of our pickups to inherit from one single class, right? So the moment we make the pickup inherit from persistent object, immediately every pickup in the game becomes savable. So this is how the bench save system is designed. Whenever you extend a component with persistent object, you'll get a new little field here called save ID, and any object that you want to save the state of. Right now, remember that our pickups are not savable. So whenever we pick something up and you come back to the level, the pickups will still be there instead of saving the progress. So for example, if you have an upgrade pickup, or if you have, let's say, hearts lying around, right? You can pick it up, you can leave the map, you can come back, and then the heart will respawn, which of course is less than ideal, right? So to save the status of items that are picked up, we can just generate a new save ID. Or you can just write your own. So for example, if you know how to track this, you can always just put pickup 001. Or you can name it like health upgrade pickup 001. You can give it any save ID, or you can generate one. If you generate one, it's always going to be unique. So it's really up to you what you want to use. Personally, I prefer to generate and then give it a unique name. So like for example, health pickup. You have to make sure that this ID is unique across the entire project, because if you have the same ID, right, for an object in different scenes, then they will be using the same save data. So you have to make sure that it's different, right? It's very important. And once you key in a save data, a valid save data, you will see the floppy disk that appears on each of your persistent objects will turn green. So green means that this is a persistent object that is getting saved. And then red means that this is a persistent object, but because it doesn't have a save ID, it doesn't get saved. And this is supposed to make the entire process of saving a lot more visual. This was how the asset was designed. So with this, we have implemented saving for our pickups. Doesn't mean that right now the pickup saves, because later on we will hook the actual save function, right, to game manager. So whenever certain things happen only, then the game saves itself. So for example, in Hollow Knight, the game only saves itself when you bench. So you will have to find the bench and then press F, and then you will sit onto the bench, and that's when the saving happens. All right. So what we are doing with the pickup here is just to implement the methodology of we are just telling the bench save system how the pickup data is to be handled when we save the game. Because there are a couple of objects that we are saving in the game, right? We will be implementing the save function on our other scripts as well. And one of these will be the player controller. So the player controller, before we actually do the saving, right, you will see that the player controller actually has one thing that is a little bit inefficient about it, and that is that right now we are maintaining a list of the player states by having a separate component with a bunch of booleans. And what I'm gonna do is that these bunch of booleans will be moved into the player controller, just like how our abilities have this thing where we can select multiple abilities. And we're gonna just implement the same system just to remove one component from the player controller and make everything a little more compact, a little bit more efficient. All right, so this involves creating a new state variable and a new state enum. It's the same as what we have done for the abilities field in the last part of this series. And also we create two functions, one function to help us set the state, and then one function to help us check whether the state is active or not. Sorry, there's two functions here because we have one set that turns it on or off, and then one that flips it. So if it's on, it turns it off. If it's off, it turns it on. All right, so then the rest of the changes to the player controller, right, is just to replace the player state list. And we'll also be removing any references to the save data script, which is right here, because we are no longer going to use save data to save. Right, so anything that has to do with loading player data, we also remove from our player controller, and the rest of the code is just replacing the checks. So wherever we use the p-state variables, which are right here, we'll be instead using the new state variable that we will be creating for the player controller. So there is also a small reshuffling of the functions for the player character as well, because over here we have two checks. We used to have two checks for is alive, right here and right here. So the code could be run more efficiently if we move these variables inside, and then this logic for terminating the update function when the player is not alive can then be moved right here. So we only do the check for whether the player is alive once instead of multiple times. All right, and rest of the code here, rest of the changes here is just change the way that we check for the state of the player. All right, makes storing of the states more efficient. So a little bit of cleanup. And I don't think there's anything else here that I need to explain. It's just a very long script for the player controller. So let me just grab this script and copy this and paste this into the player controller. There are other changes as well that later I will explain. Yesterday when I went through the code, it was actually pretty fast. So I'm hoping that this part, the recording itself won't be too long. So once I change the state variable for the player controller, right, you will see a bunch of errors occur. A bunch of errors appear, and that's because all of these scripts here, right, refer to the old player state component, which we will have to remove. So let's go to the enemy script as well. Okay, enemy script, wherever we refer to the player's state using the p-state variable, we will now have to use the new is function to check if the player is invincible. And same thing here, check whether the player is alive. We'll use the is function that we've created for the player controller. So all these changes apply to all the upcoming scripts that we will be modifying, or rather that I'll be modifying. So the first one is enemy. Just clean up the spacing right here as well. And then for the bat, for the shape, and then the charger. Charger is different enemy type. The crawler, which is again a different enemy. So all of these scripts are just referring to the p-state variable, which are changed. Very straightforward. And the interesting part will come when we start modifying the when we start defining the save logic for the game. Then yeah, that's where I have to do more explanation. So diving pillar, all these are just scripts from previous parts. Just changing these scripts to use the new variables instead of the old one. The scene transition script here is I wouldn't say it's particularly important, but later on we'll make a couple of changes to that as well. If you are my editor, you don't have to put this in the Final Cut. Just leave this out, just rambling at this point. So THK events. Where is it? THK events, right here. So once all these scripts are updated, there's spawn boss as well. Wow, there's a lot of scripts. And with spikes. I think that's the last of them. Oh, and the Hollow Knight. It's not the last of them yet. There's a couple of lines here that we actually don't need. Let me just remove them. Don't need these two as well. So once all of these are applied, you will still see one last error, and this last error here, right, is saying that this line has an error. So you might be wondering what this bench.save game does, because our bench script is actually a script that we have in our game, and it's the script for the save point. But because the asset itself, right, also uses, sorry. Because the asset itself, right, also uses the bench class, there is a conflict between the bench script that is in our project right here. So our project has a bench script, this one. And then the asset that we are going to be using, right, the asset that we've downloaded also has a bench script, which is a scriptable object right here. So how do we navigate this issue? The asset that we have, right, the full name for the bench class in our asset is actually terrasquall.bench, whereas the bench script that we have here is just referred to, you can just refer to it by just saying, using bench. So to differentiate between the bench in our project and the bench in the save system, we will have to fully qualify the class name that the assets class has. Later on, we're going to change the name of this other bench script. We're going to change this other name to save point, because it's just to deconflict. Because if the two names are in conflict right now, right, whenever we want to refer to the bench save system, we'll have to put in terrasquall.bench.savegame in front. So in the codes that we're going to be showing you, the bench.savegame here does not have a terrasquall in front, because we are going to factor in the fact that we will rename our bench class later on. But if the errors bother you, because right now if you do not put the this terrasquall.bench in front, right, your script will not run until we rename the save point. So if you want to, along the way, if you want to make sure that your scripts work, you can just temporarily add terrasquall in front first. Once we change the name of our bench script, then this section here will not be necessary. Alright, so if you run into errors, just put terrasquall dot in front of your bench save game or bench load game calls. Okay, I will just show you the issues whenever they arise. So once I fix this error, you will see that now the player controller has successfully implemented the new way of storing the player state, which is to use a state variable right here. And then with this, we can actually remove the player state list like this. Let me just, instead of removing it here, let me just go into the prefab and remove it there. So open this and remove the player state list here, because it's no longer needed, right? Okay. And in the player state itself, right, I'll also have to make sure that the player is looking right and the player is alive as well. That will be the default state the player has. But again, I wanna apply this to the prefab. I don't want to apply this to the player in just one scene. because this applies across the whole game, right? Let me move this up. I think my screen was blocking. I'm gonna set this to alive and think right. So with that done, right, the next thing we will do is to implement the save and load functionality in our player controller as well. And we are doing the same thing here where we apply a persistent object onto our player controller script instead of applying the model behavior class. And then this is just a saving namespace that we'll need. And this scene management here allows the player controller to load other scenes wherever necessary, because we have to save the scene name later on when we modify the player controller to spawn a shade whenever the player dies. So this namespace here is not used. I'm not sure why it was in the original code, but that's why I'm removing this. And the main next change right now, right, for the player controller script is the save and load functions. Again, these save and load functions, they define how the player handles saving and loading, and as well as what properties are saved by the player. So first we have, let's look at the save function right here. The save function saves more or less the same thing that the save data saves. We save, of course, the save ID, we save the health, max health, total health, heart shards, mana, mana penalty, mana orbs, orb shards, unlocked positions. I think the mana here, okay, let's ignore this. Saves the ability, saves the last position and the last scene as well. I'll explain more about this position thing. Okay, let's look at the load. Load is just the same thing except that it's the opposite. We first check whether there's any data. If there's no data, we stop the loading, and if there's data, we'll convert it to the player's save data, and then we'll load the health, mana, same thing, same. Okay, the interesting thing here is the save data. So for every save data, every object that you want to save data of, you have to define a save data class, right? We did the same thing with the pickup as well, but because pickup only saved one property, which was whether it was used, we always have to extend persistent object save data like this. And then here we just define all the properties that we are saving. Okay, note that I think this was covered when we built the first save system, but you cannot save vector 3s, vector 2s. You can only save primitives. So that's floats, integers, bytes, strings, and some other any variable that is small letter that is default in C# can be saved. Anything outside of that, most of them cannot be saved. So instead of saving a vector 3, we have to save the x, the y, and the z. But to get around this, we can actually define a getter and setter. So over here, I define a getter called position that if you try and get the position, it gets you x, y, and z packed into a vector 3. And if you try to set the position itself, right, it helps you set the x, y, and z values. That is why even though we cannot save vectors, right, in the save function, we can still assign the transform.position, which is a vector 3, into the position variable right here. Okay, so we're defining the save and load functions. We're defining what data is getting saved. So let's drop this into our project. And there should be no errors that appear, except for right now we have the same error with the save game. So let me just add this TerraSquare qualifier in front of this function to remove the error first. Again, if you want to just copy everything first before you look at your project, you can ignore this last error with the save game. So with that, now our player controller is able to be saved. And then we can move on and update our game manager. So the game manager is where the magic really happens, because this is where we are moving all the save data functionality to. Okay, so you will realize the old save system, right? Basically, at various points in our, let me just grab the script. Where is the script? At various points in our game logic, right, it will call a variety of functions like save bench, load bench, save player data, load player data, and then it saves data about the shade as well. As well as the boss data, right? So we're gonna move all of this functionality for saving, right into the game manager script. So we'll be removing this old save data script, which I don't want you to confuse this with the save data scripts, the save data classes that we have inside of each of our classes. So the save data that you find right here inside of the player controller, for example, is different from this save data instance. And let me just use Notepad to illustrate this point. So if we put a save data inside player controller, right, the fully qualified name of this save data class, notice there is a new here, and that's because in persistent object there is also a save data class. All right, so we have a save data class inside persistent object. So we have a couple of save data classes. We have persistent object save data right here, and then we have for each of our individual objects, we have a save data class as well. So these are all different objects, different kinds of objects. They are one kind of save data, but it's not the same as the save data that we have created for this game previously. So right now we're going to create a new save data for game manager as well. And the old save data is just saved. The actual name for the old save data is actually just save data like this. Okay. So instead of having one save data class to rule them all, we have multiple save data classes to define what kind of data each of these objects save, and they are all inheriting from this persistent object save data class. These are nested classes, which means that they are accessible from inside of another class itself. So when you're inside the class and you refer to save data, you're referring to the class's save data. So for example, right, in player controller, let's say, under the save function, you will notice that here I'm creating a new save data. This does not refer to the save data here. It refers to the save data that is inside of the player class, which is this save data class. All right, so with this new way of recording save data that the bench universal save system provides, right, it makes it so much easier for us to manage the save data because it's managed at a class level. So every single object, every single component in our game that needs to be saved will define its own save data instead of having everything defined by a class like that, which makes everything honestly very messy, right? The old save data class, you will see it handles player health, it handles the shade, it handles player abilities, handles whether bosses are defeated. It's a whole bunch of stuff, and really it just gets confusing when you start to record multiple things. And you'll notice that the reason why our old save system didn't save pickups was just because it was very hard to track pickups using a system like that. How do you do it? I mean, it's possible, but you will be using a bunch of arrays, and that will be pretty annoying to deal with. So the game manager is gonna apply the same thing here. So again, it inherits persistent object, and the game manager will do things a little differently because it also has a static save data object called global data, and this save data references the save data that we'll later define for the game manager. And the save data here basically saves a couple of things. Okay, there's something wrong right here. Let me just modify this game manager. Game manager. The save data doesn't actually save the. This is not saved, right? This. I'll explain this later once I'm done. Explain what's going on. Just a little typo here. I've got to modify. This last scene here is no longer used. So the game manager will save a couple of global game state attributes. Like under this new save data object here, it will save where is the last scene we have visited, Beyond that, it's responsible for tracking whether a shade is in our game, and if the shade is in our game, then where it is, and of course where it's faced, which scene it's on, and the position and the rotation attributes. It also saves something called flags, and flags are global they're like global how do I explain it? Okay, let me just tell you what flags is. Flags is an enumeration that we define inside the game manager itself, and it's there to save different states that the game has. So right now you will see the THK defeated variable is moved into a flag right here. Later on, when we implement the game manager, I'll show you how this drop down looks like. Alright, so it has a similar system as the state in the player controller, where you check whether a flag is on, or you check whether a flag or you set whether a flag is on or off. So as we develop our game, right, and we have more states, like for example, flags can be used to track which bosses are defeated. They can also be used to track other things, like say whether you have spoken to an NPC and progressed through the game, or whether you have, say, retrieved in Hollow Knight we have this dream nail, right? So these flags can be used to track all of these things. Okay, so with flags, right, there's a limit to how many flags you can store. So flags have to be powers of 2. Otherwise, if you look at the player controller state, for example, right, the state flags also have a power of 2. So right here you will see the state flags also they are also in powers of 2. Alright, the reason for that is because when you want flags to be able to be multi-selected like this, or like abilities, right? If you want multiple flags to be selected, they have to be multiples of 2. Okay, if you want an explanation for that, we have a short that we will link in the video description below that explains how these flag enums work, but they are basically more efficient ways of storing Boolean variables. Alright, so we are going to pack all of our game variables into a flag like this, and then we are going to save it inside our save data. Okay, and then we also have shape position, shape rotation. This is the same idea as what we had in our player controller beforehand, where this is just a very easy way for us to save the shape position and shape rotation when we have in our save and load functions. Alright, because again, in save data, we cannot save the vector 3, or we cannot save the quaternions. So we have to save the values as floats, but then we can always create helper getters and setters to make it so that even though we cannot save the vector 3 and the quaternion, we can still actually just use the shape position and shape rotation variables to set them very quickly. So our save and load functions are very simple because the save data, right, actually is saved in a static variable like this. So this works a little different from our player controller and pickup. Because all the time, right, the game manager will be maintaining a copy of a save data. It's called global data. So anytime you want to modify, for example, the shade, where it is, and what rotation it is, what scene it is, we'll just use game manager.global data. Let's say I want to change like the state, the shade's position. I want to move it somewhere else. I can always just do something like this. Or if I want to change, for example, I want to make the let's see, where is the set function? So for example, over here we have a set flag. So for example, I want to set that the say a certain boss has been defeated. I can just use this set function which changes the global data right here. I can just do a set like this, THK defeated. And I can set this to true, for example, if I want to change the state of the game. So once all this is done, the game manager can call save game, and all of this data that has been set will be saved. Okay, so the game manager maintains a state for global data at all times, and this makes it so that we can very easily retrieve data from global data as well. Later on, there will be some examples that I'll show you. Okay, once all that is done, we are just changing in the game manager the way that the shade is spawned instead of using the save data, right? Here we are spawning the shade if there is a shade in the scene. So again, this shade scene here under global data tracks whether there is a shade in our game, and if there is, then we will spawn the shade. This is for whenever we change scenes, right? Because if there is a shade in our scene and we change scenes, then this is actually the shade doesn't automatically transfer to the other scene. We still have to make sure that if there is a shade in our scene, then it manually gets created every time we enter the scene. We also have an async here. So here we have some code about updating the map, which we will update later as well. And then we're just removing the old code for spawning the shade because it uses the old saving system, and this bench object as well uses the old save system. So everything that relates to the old save system is removed. We have an async function. The start here is an async function because we want to wait 100 milliseconds before we do a quick load. So the quick load from the bench save system, right, is different from a load game, and that quick load, basically whenever you load a game, a copy of the save file is saved inside your RAM. And then this is so that, let's say if you want to just save data across scenes, right, instead of using save game and load game, which writes into your hard disk, you can use quick save and quick load to just save the current state of the game without actually modifying the actual files that are saved. Quick save and quick load is just when you want to save without, because when you write data into the hard drive, it takes very long. Okay, so we want to make sure that whenever we enter a new scene, right, that all the data in the new scene is up to date. So for example, the pickups in each scene, whenever we enter a scene, the pickups are preset, and quick load will remove the pickups that we already have picked up. This should be gone. There's a little bit of an error here. So pickup. I don't know why it's right here. Typo. So by delaying the start function from calling by 100 milliseconds, right, which is 1/10 of a second, we ensure that everything is loaded before we try and load our save data into our individual game objects in the game. And once it's done, we also, here again, we try and spawn a shade if no shade has been spawned. All right, so we can call the spawn shade multiple times, right? Because for the awake function spawns the shade when we first enter a map and there is data about the shade. But because the game is loaded later, right? Okay, in the awake function, when we try and spawn the shade, sometimes there will be no shade data. Okay, depends on which part. If you've just loaded the game, then there will be no shade data until you first load the data into the game itself. All right, so we have two areas where we try to spawn the shade. This doesn't cause us to have two shades. It still causes us to only have one shade because in our spawn shade function right here in the game manager, it tracks the current shade that the game manager is having, and if there is already a shade, it will prevent the spawning of a second shade. So even though we try to spawn the shade twice just to ensure that the shade is always there, there is a failsafe here that ensures that we won't get more than one shade in our scene. Sorry, it's right here. And the rest of the code is just removing anytime we have references to save data, we just remove it because the old save system, right, no longer needed. We have some quality of life improvements here as well. So the reset function is just made so that the save ID for our game manager, right, will always say game manager. This is because we want our game manager to transfer across scenes, no matter which scene we are on, right? Whenever the game manager is there, it's supposed to be the same as the game manager from other scenes. So they all should have the same save ID. Otherwise, they will not be able to retrieve each other's data. Okay, this is really important. Later on in the interface, I'll emphasize this again. And then these two are just quality of life because our game manager has a couple of variables that need to be set. And by setting them automatically, this helps us to maintain our game manager a little bit easier. Where is the game manager? Isn't it here? game manager is canvas. Yeah, right here. Okay, so right now we have a couple of errors with our code once we save the game manager. So let me just finish explaining the rest of this code first. The rest of it is just we have update map here, which implements a new map manager. So we're gonna have to implement a couple more scripts before I can show you the changes made to game manager. We have the old save game removed because it uses the old save system. The respawn player also gets updated because it uses the new way that we are, because the respawn system, right, also uses the old save system. So we are just updating the code so that now it uses the new save system. And then of course we have the save and the load functions, which are pretty straightforward. Here the save function just saves whatever is in the global data variable, and the load function just loads everything that we have into the global data variable as well. And then the flags and the save data I've explained. So we'll just copy the script into our game manager script right here. And you will see a couple of errors, and this is because the old game manager script changes a few things, a few variables, and we have to update our functions. The first thing it changes, because the game manager changes the way that the shade works, right? We'll also have to change our shade code to use the new save system. The shade uses the old save system, and we'll make it so that now whenever the shade is spawned, automatically it will save the scene that it spawns in, as well as its position and rotation. This is for the game manager, again, to know when to spawn the shade. Beyond that, there are no other changes. Besides, right now, whenever the shade dies, we also want to save the game as well. Okay, save game async is different from just a regular save game function. Save game itself, right, will cause, when you play games, whatever game you play, whenever you try to save the game, you'll notice that there is a brief lag or brief pause. The game will spike a little bit. If you want to avoid most of that, you can use save game async. Save game async basically starts a different thread to save the game. If you just call save game without the async, right, whenever you save the game, the whole game will pause until the saving is finished. So it depends on what kind of save style you prefer. For modern games, usually an asynchronous save system is applied, so that even when the game is saving, you can still continue to play the game. So after the shade dies, then we'll have to make sure the game manager is notified, because we empty out the shade scene variable inside the game manager. And of course, this replaces the old save system that we have here. So a couple of changes to the shade code. It's complementary to the game manager changes that we've made. And we also have to update the scene transition script, because the scene transition script uses the old way of saving the shade data, which anyway doesn't always work. So we are replacing that, and because the saving is now done by the game manager, right? Now in the scene transition, whenever the player moves from one scene to another, instead of checking the shade data, we will just do a quick save right here. And then in the player controller itself, we have to change the way the shade is spawned. I know there's a lot of code in player controller, but it's really just one line of code. And that is, we are changing the way the shade is instantiated. Instead of instantiating it ourselves, we use the spawn shade function from the game manager, right? So that again, the spawn shade function tracks whether there are any shades, and it prevents any shades from being spawned if shades already exist. So because we have changed the way that the game manager handles some of the variables, most notably the THK defeated boolean, we'll have to move on and update the rest of our the rest of our scripts as well. But before we do that, right, we are also going to, because the old save data actually tracks which maps, which scenes we have been into, and then updates the map accordingly, right? We'll be updating the map manager to handle the saving of the maps for us, instead of having a centralized save data handle it for us. So the map manager also has a persistent object, and then it has save data as well. That basically it just does one thing. If a map is active, it activates the map, otherwise it deactivates it, right? It's just that now it's reading from a different place for the save data. So right here under on enable, right, whenever the map manager turns on, we have this load function right here. That is the save and load function that we have. So what we are trying to do here is that whenever the map manager is turned on, we will try and load its data by using bench quick load like this. So here we're just loading a single object. And yeah, so it just saves the scenes we have visited as well as the current maps that are reviewed. So if you look at the map manager script, right, the main logic here is that whenever we try and save the game, then the maps that we have is updated with the scenes that we have visited. So this corresponds to how in Hollow Knight, right, whenever you visit a new area, you actually don't get the map from new area until you sit down onto a bench and save, and then that's when you get a new area for the map for new area popping up in your map pop up. If you've played Hollow Knight, you will know what I'm talking about. So we are updating the map manager to save its own data for map management, and we update the map manager script here as well. So then the last thing we will do is just to address all of these errors. There is a quick load here. Again, because we haven't updated our bench save point, I'll just add a new TerraSquirrel dot bench to differentiate it from the bench class that we have. Same thing with the game manager here. Just add a TerraSquirrel bench temporarily. And the rest of the errors here are just to replace, because the THK defeated variable has been replaced, we just have to go into each of these scripts. Okay, and then we have to change the flag here. Instead of checking the THK defeated flag here, we have to, it's just a new way of setting the flags. So the first script is THK events, which we will go in and replace. Where is that THK events? And then next is spawn boss. Update this as well. So we just got to update all references of all parts of our script that refer to the THK defeated variable. Now you'll have a more organized way of referring to the variable itself. Map manager, same thing. Oh, hold on, map manager has errors. Haven't we already updated the map manager? So as you can see, this part is quite tricky. There's quite a few things happening over here. I have to remove the map manager script. So there's two of them. Second one shouldn't be here. I think the map manager save visited scenes. Yeah, I'm pretty sure this is not needed anymore then. Right, let's remove this. Yes. So this guy should be gone as well. So with that done, we have to retool scripts. So we have events and spawn bots, just two of them actually. It's pretty straightforward. So the errors will keep popping up if you copy the scripts that we have, because some of them don't have the TerraSquare namespace at the back. Just address that. Okay, so the last error you'll get is that the game manager does not contain definition for THK defeated. This is because the old save data class, right, also has issues because it refers to old variables in game manager. So there are two things you can do. You can either remove the lines right here, or you can just remove the save data class entirely to solve the issue, because we are no longer using the old save data script, right? So I'm going to delete this to solve this issue here. And this will bring us to the next problem, because the save data script, right, actually is referred to by both our scene transition variable, and which we've removed, right, actually, and the save point variable. Okay, so here I'm just gonna grab the save point script. This modifies our old bench script, right? So this is gonna be changed to save point. So before you copy the code, right, what you want to do is right click on your bench here and click on rename, and then rename it to save point like this. So this is so that your file changes the name as well, and then now you can copy and paste the new code. All right, so the new bench script, right, basically what it does is that it again implements persistent object. The strange unique thing about the bench script is that besides replacing the old save system, it also has a save and load function that is empty. All right, why is this? This is because our game manager, right, even though the bench itself doesn't have data to save, the save ID will be used by the game manager to identify which bench the player saved at. This is much more effective than getting the player to just spawn at the bench, because later on what we want to do as well is we want the player to sit on the bench. I made a sprite. So we want, when we save the game, for the player to sit on the bench. All right, so we'll have to modify the way that the bench is tracked, and we'll need a save ID for that. So now we'll go to the player controller and add two functions, rest and unrest. Rest will put the player on the bench, and then unrest will remove the player from the bench. So once this is copied, then I'll be able to show you all the features that we have implemented, because a lot of these features are actually whenever we implement a new feature, there's an error. So we need to get the errors to all go away. And finally, we need to modify game manager and add a new variable under the save data, and that is called the bench save ID right here. So we add a new bench save ID to the game manager, and then we make sure that whenever the player dies, we will set the respawn point to be the last bench. So let's update the game manager with these as well. So with all of that, we should no longer have errors in our script. Why does the save data have a definition for visited scene? Okay, this is just a little bit of an error with the manager. Because it should no longer use visited scene, right? Visited. So it should be I'm glad I'm doing this recording, because otherwise I wouldn't have noticed all these little errors that my script have. We're almost able to test the changes. Let me just recopy this. So all the errors are gone. Now let me show you all the changes that we've made to our game so far now. It's much easier for me to show everything to you now. Okay, first thing is you got to make sure that when you, after you are done with updating the scripts and all the errors are gone, then you will have to look at the inspector and make sure that all your components set up properly. And the most important thing really you want to pay attention to is the save ID for your game manager. To modify the save ID, I suggest you do not modify the scene themselves, the scene itself, but go to the prefab. Open the canvas prefab where our game manager is. Let me just slide this up so you can see the component. And make sure that you set a save ID for your game manager. One way you can do it is to just do a reset. Alright? But I suggest instead for you to just type in game manager on the prefab itself, instead of resetting it. And this will apply the game manager save ID to all your objects. Make sure that all your game managers have the save ID game manager. This is so that even when you jump across scenes, right? Okay, your objects still use the same save ID, so they will share the save data, right? Because save ID is same and you only ever have one game manager in your game. That's the first thing. Second thing is I just want to show the bench, how it works. Because for our benches, right, everywhere in our game where benches exist, we'll have to give it a unique ID. So like right here, right, this ID is gonna be across the game. So I'll generate a new save ID here. I'll just call it bench, right, in front. So the save ID has to be unique so that when we load the game, right, the game manager is able to identify which bench we set on. The other thing you will see is that there is an anchor. This anchor determines where the player is attached to when the player sits on the bench. So you want to just shift the anchor around somewhere above. And this is because the player's anchor point is actually above on the head. So the anchor on the bench will determine where the player's head is later on, right here. So the point here aligns with the player's head. And that's all we have to worry about. Just gotta check our scenes to make sure that every scene that has a bench has the anchors properly set. I don't think there is a bench in this scene. Okay, that's great. So now the player controller should be able to save the game as well, right? So now when you try and save the game, one thing you will notice is that if I save, the player sits on the bench like this. Okay, but there is no sitting animation, which is something that we will have to add into the game as well. The sitting animation, have I added the, I don't think I've added here. Let me just move it from the other tutorial, the other set of files I have. So I've created a sitting animation, which I should add into the article itself. The sitting animation is right here. I have just one sitting sprite that I'm gonna import into my project. Under the art folder, I'll then drop it into the night files and then night png. So we have a sitting here, and what I also want to do is to create a new sitting animation for the night, which I'll have to do by going to player, opening the animation window. So the sitting animation, right, will be consisted of a couple of frames. Let me just create a new animation for player sitting. Alright, so player sitting will have the player hop onto the bench onto the bench and off the bench, which means we can find a couple of hop animations that work. So right here, so I'll drop these 4 frames. 5 frames right here. Sprite render, right? And then finally, we have the sitting animation that we've just added, which is right here. So what the player is going to do when he hops onto the chair is like this. Alright, so this is what we need. And we can reduce the samples as well to reduce the speed of the animation. Alright, so then once we have the animation set up, next thing we have to do is go to the animator. And a couple of things we will have to do in the animator right here. For the player, I'm gonna have to... Okay, I forgot how the animation is set up actually. Let's work it out. First, we have to add a parameter, and the parameter is, let's see, set rest. So the rest function has uses a resting parameter, which means I'll have to just add a new parameter here. It's Boolean, it's called resting. So if the player is resting, it hops onto the bench and it plays the sitting animation. And we'll just go and grab the sitting animation for the player. We'll place it here. Sorry, the sitting animation is actually already inside the animator here. So the easy way to do it is we can just make it so that if the player is walking or jumping, or if the player is idle, it's going to be able to go into the sitting animation. Okay, one way to do it is like this. The other way is to drag from any state to sitting like this. And then when the player is done sitting, it just links back to idle. Okay, so the activation for this, right, would be for the player to, firstly, there's no transition from any state to sitting. And actually, it's much better if we just set fixed animation. So idle, walk, and actually any state it should be able to. Let's do jump as well. Okay, so any one of these states, and when the player is in any one of these states, it should be able to start sitting. We want to make sure that all of these transitions, right? Actually, it's best to do any state because there's so many arrows here. So I'm just gonna arrow here to player sitting. There's no exit time, no transition, and the condition is just that when the, let me see if see the condition here is just going to be resting. Resting is true, then you can go into sitting, and then when you get out of sitting, you just go back to idle like this. All right, so then you have 2 arrows here. And for sitting, there is again, there is no exit time. Let me see. Now this is how it should work. So it goes in, and then it plays that animation, right? And it doesn't loop. We have to make sure the sitting animation doesn't loop. You gotta make sure that the sitting animation here is selected and the loop time is 0. So then when you go back to the animator, doesn't loop. Then we'll create another sitting animation that's like the reverse. So this will be player unsit, and it's going to be a speed of -1 because it's the reverse of the animation. So then when you are getting off the seat, this is when resting is equals to false. There is no exit time. Oh no, there is actually exit time with 1. And we will just link unset back to idle. Tips. Actually, there shouldn't be an exit time. Let me just remove the exit time. So the exit time should be right here. Only when you are unsitting, you have to make sure the entire animation plays before you go back to idle. So anytime the player can sit if you activate rest, and then it will unsit itself when you unrest, and then it goes back to idle. So with this added to the animator, right, we will be able to let the player sit down when the saving takes place. So the player seems to be frozen on the sitting animation. Let me just debug this, figure out what's wrong. Why is the player not playing the animation? Maybe I will have to set this to come from idle instead then. Maybe that will work. I'm just playing around with the possibilities here. I think with if it goes from idle, it will work. There we go. So I'm just gonna play around with the animations a little bit, yeah. So if it's idling and it's walking and it's jumping, I want the player to be able to transit over. So I'll just set resting to true to all of these. Probably this will take a little bit more refining. I probably will re-record this part about how to set up the animations, because it's a little tricky right here. A couple of bugs that will occur if I don't set this up properly. No exit time for each of them. And the transition here will have no exit time as well, but this one has an exit time, maybe just a short one. Actually, there is no exit time, right? What's gonna happen? It needs an exit time, right? 0.1 maybe. Because right now it stays there for too long. The animation stays for too long. It's not great. That's because the player walk here. Why did it stay so? Oh, it's just transition duration. So if there is no transition duration, actually it works just fine. So 4 frames pretty fast, you know. There we go. So now the player hops onto the bench. It just needs to, with the animation set up here, it just needs to, I just need to make sure that the bench itself, right? Let me just double click into the bench. The bench itself is on the ground. That's one thing. And the other thing I need to make sure of is that the anchor is in the right place. It's not high enough. So I'll move it higher and I'll just do another test. See whether the player hops onto the bench itself. The anchor determines how high the player goes. So if the player doesn't go high enough, then we have to change the anchor. Alright, so let me increase the anchor a little bit more again. Pops on. So once we start saving, right now you will see that in the settings object, or you can go to window and Terrascore bench universal save system. Either one of these windows, you can use it to check the data that is being saved. So the player character is not saving right now. Not sure why is that. I guess there'll be some parts of this recording where I'll have to re-record stuff. The player isn't getting saved. It means that the player controller script perhaps is not working properly. But let me just finish up this recording and then we'll make edits as we need to do so. So one thing that you can do, right, as well is you can actually look at when you are playing the game, right, the bench window will actually show you the current save file. So I can just do a save and it shows you everything that's been saved. So then there's slot 1 as well. Wow. Is this saving in slot 1? Slot 0. Slot 1 there's save data here. That's slot 0 there isn't. Okay, I'll work out the issue with why the slot 0 doesn't save the player data. It's just probably an editor issue. Next thing is one thing that you will see that's very handy in the bench universal save system is that there is a save indicator that you can use right away. I'm just gonna go to canvas and show you how this works. So open canvas and you can just drop the save indicator on your canvas itself, and this will cause a save indicator to show up whenever I'm trying to save a prefab, for instance. So you'll find this little prefab for the save indicator inside the asset. And what you want to do is just to go to bench and then grab the save indicator prefab, and you can go to your canvas object and just drop the default indicator inside your canvas. So doing this will automatically put a save indicator on the bottom right side of your screen, so that whenever you save the game, you will see this little indicator appear. So when I save the game, very conveniently, the save indicator appears for a while before it disappears. It's a great way for you to show players that their game is being saved. So the last thing we will have to do, right, is to, after all of this, we will have to modify our main menu, right, so that it uses the save slots that come with the bench universal save system. So let's go over to the main menu scene. I'm just going to save all my changes in Cave 1. And here we have the start. And then what I'll do, right, is we'll go to prefabs under the bench universal save system and then look at the save slot UI. We will drop the native save slot UI over here. And right away, you will see some save slots appear. And this UI will by default be disabled, because what we want to do here is, before we disable it, right, let's add a UI screen, which is one of the scripts that we created in part 13 of our series, when we created a UI system to manage all of the things that are happening with UI. Just make sure that the UI screen settings, right, is similar to what we have in main menu, options menu, and etc. meaning that the settings here are the same. Okay, once we have that, for the feedback config, we can just use the default as well. All right, and do we need a crossfade? Yeah, we can do a crossfade here as well, 0.5. So once we have that, we will disable the native UI save canvas first, because when we have the start button, right, we will replace this click event from the start button with this native, and then we will just do an activate right here. So we'll activate and then check this so that it closes the other screen. So what we are doing with this right now is that we make it so that when we start, click on the start button, it actually brings us over to the save games screen, and then we have all these slots. For the slots themselves, right, what you want to do is, I'm just going to re-enable this again. You'll want to go into the save slot manager and then make sure that you set the number of slots is set inside bench save right here. So by default, there are 5 slots. So we can actually just go to UI save slot manager and click on generate slot elements, and this will give me all the save slots. So once you have all the save slots set up, I'll deactivate this save UI canvas again. You will see that when you go into the game itself, it will just show you all the slots that are filled up and all the slots that are not right here. So because I have some saves in slot 1, slot 2, and slot 4, then data shows up, and then wherever there's no save file, it doesn't show up. All right. So automatically, this save canvas actually saves the amount of time that you spend on the game as well as the version of the game. This version of the game here is saved inside project settings. Now, where is it? It's under player, and you will find the version is under resolution. No, sorry, it's here. All right, so that's really all you need to do for the save slot manager. Is there anything else we have changed? Let's see. Slots. Oh yes, so inside the save slot manager, there's actually also individual slots. There's save slot template over here, which is going to enable this again, and I'll just temporarily hide the canvas so we can work on the native UI. So we want to just make sure that the first save slot template, right, we can actually modify a couple of things on the save slot itself to control how the save slot displays. So here we can change, for example, the playtime format. Okay, we can change the way the date is presented as well. Okay, so there are quite a couple of settings that you can play around with here that are pretty cool. And then you can control the text that appears. Let's say if there's no save game, you can control what appears here. And you can also control what metadata is being shown. So here it shows the current scene name. And then if you have a display here, right, you can, for example, put level here and then click on update save slots, and this will show you like level in front. So you're gonna have to play around with the settings a little bit here to configure the save slots into the format that you want. And with time also, like, so you can add a title here like playtime, update save slots, and this will give you like a playtime text here. Oh, this is save time, right? Save time. Okay. So you have to play around the settings to see what works for you. Okay, and then you can also, for example, there is a little space here. This is because here the display has /n, which is a new line. So a couple of ways you can customize the visuals of the save slot template. Once all this is done, you want to go back to save slot manager and then make sure that you duplicate the slot settings over to every slot that we have here. Okay, so the save slot system, right, is just designed to work. So you don't have to worry about doing a lot of setups. A lot of times if you use just the prefab itself, you drop it into your scene, activate, deactivate it, and it will start working. Right, so if I click on cave 1, it loads, for example, the first cave right here, and I can start playing. And when I save the game and I go back to the main menu, you will see that the playtime actually updates itself. See that? It updates to 12 seconds. So if I pick stuff up, Okay, this actually doesn't save, and the reason it doesn't save is because don't forget that our cave 1 scene here, right? Let me just save the changes in the main menu. The K1 scene, after you are done setting up the save system and you see that the playtime actually updates, right? Next thing you want to do is make sure that all of the objects that are supposed to be saved have a save ID. That's very important. Okay, this is upgrade, pick up, and here we have so in the future, probably as this bench save system gets more developed, there will also be other tools that will be added to the window to help you check in your scene whether there's anything that doesn't have a proper save ID that's set up. So if I have the save ID properly set up, right, when I load the game right now, it should probably save the data for these pickups. So let me just show you how this works. So I'm gonna load into slot 1. I'll pick up Monarch Wings. And let's go to the bench save system to check whether data is being saved. Right now it's actually not being saved. But once I go to the bench, right, it should actually save my data and this updates. So I'm not sure why the player character is not getting saved, but well, we'll just have to figure out what's wrong here. Player character is not getting saved. Is it because there's nothing for the player character to save? Anyway, if I save the game and quit, you'll see the playtime advances. It's just that the player state doesn't get saved, but the pickups do get saved, so whatever I've picked up actually doesn't appear. So it's 46 seconds now. And then the pickups, because they're configured to be saved, they never appear again because the save system, well, to put it very simply, it's working. Player controller has a bug, which I want to fix before I end the stream. I probably will have to record some other things outside because a lot of issues with save system here, it seems. Oh, the player character is not saving for a very simple reason. The very simple reason is that the player character does not issue the save ID. So I'm just gonna issue the save ID. Silly me, right? Just make sure that in your player prefab you apply the save ID to the player, otherwise the player won't save. Because the player is the same across all levels, right? You just have to make sure that we issue a save ID here. Doesn't matter that it's duplicate. It's supposed to be a duplicate, right? So we can revert. Make sure that the save ID applies to every seed. So if we go to player here, there should be a player here as well. So once we have that, right, if I start loading the game, you will see that everything saves properly, and that, of course, is very wonderful. So right now, if I look at the bench save over here, there should be player save data now. I am so glad this part is finally done. I know that there are still a couple of small edits I have to make, but there's so much work to get the save system to work, and it's so exciting to get everything done now. So then we'll release a video and we'll release the asset as well. I've been working on this for the past 3 months. Don't know how happy I am to be done with this finally, and to see all the UI actually work, and you know, all this bullshit here. It's all bullshit, right? So much data here, and there's a lot of time spent, and I hope that this video, when it comes out, it helps you, whoever you are, and it helps make saving more accessible to you as a developer. So thank you very much for your support. After Silk Song came out, there was actually a lot more Patreons coming in. That was why I came back to further the development of this Metroidvania series. So thank you so much. Let me just check the chat before I head off. I hope the whole thing was recorded, man. If it's not recorded, I will just flip out. Okay, that's all. I'll see you.